Let's look at solving a rational equation. So when we're looking at a rational equation, this is an equation that has fractions that have variables in the denominator. What we want to try to do first is to clear the fractions using the least common denominator, or LCD. So as we look at our denominators here, in our right-hand side of our equation, since the denominator is not factored, we'll start with that. So numbers that multiply to 36 but add to negative 13, we could factor this as x minus 4 times x minus 9. So looking at the left-hand side and now these factors, we can see the two types of factors that show up are x minus 4 and x minus 9. So this will be our LCD. So since we're solving an equation, as long as we do the same thing to every single term on both sides of the equation, it won't change our solution. So what we're going to do is we're going to multiply each of these three terms by the entire LCD to cancel out the fractions. So I'm going to take the x over x minus 4, and I'm going to multiply times the factors x minus 4 and x minus 9. Then I'm going to do the same thing with 3 over x minus 9. I'm going to multiply by both the x minus 4 and the x minus 9. Then I'm going to use, on the right-hand side, I'm going to go ahead and use the factored form that we found. So it had x minus 4 and x minus 9, and multiply times that entire LCD, x minus 4 and x minus 9. So we can do a lot of canceling now. So this factor of x minus 4 in the original denominator cancels with the x minus 4 from our LCD, the x minus 9 with the x minus 9, and here the x minus 4 and the x minus 9. So now we want to multiply what's left, and there should not be any fractions remaining. So we're left with x times x minus 9 plus 3 times x minus 4 is equal to 4x minus 28. So we still have an equation that we need to solve, but this equation no longer has any fractions. So we'll start with distributing x times x. We have x squared minus 9x. Distributing our 3 plus 3x minus 12 equals 4x minus 28. So we have a quadratic equation. I'm going to go ahead and get all of my terms on one side together. So I'm going to subtract 4x from both sides and add 28. So it leaves us with the simplified quadratic x squared minus 9x plus 3x and minus 4x gives us a minus 10x altogether. So minus 6 and then subtracting 4 more. And then negative 12 plus 28, we have a plus 16 equals 0. Factoring is probably your best bet for solving this one, though the quadratic formula and completing the square would also work out here. So numbers that multiply to positive 16 but add to negative 10, we can do an x minus 8 times an x minus 2 equals 0. So we end up with two solutions. So if x minus 8 equals 0, we get x equals 8. If x minus 2 equals 0, we get x equals 2. For this particular equation, we're able to keep both of these solutions. The one thing that we always have to check for when we're thinking about rational solutions is making sure that those values that we found, that if you were to come back to the original equation and plug into any of those denominators, we need to make sure that it does not make any of our denominators equal to 0. So if we had come up with solutions of either x equals 4 or x equals 9, those ones would lead to division by 0 and would be thrown out as extraneous solutions. But x equals 8 and x equals 2, if we plug those back in, do not make any of our denominators equal to 0, so we can keep both of those as the solutions to this equation.